Tonight, we are going to take a journey that quietly reshapes the way you see everything around you. Not just the sky above your head, but the ground beneath your feet. Not just the stars, but yourself. This is a journey about scale. About perspective. About discovering just how small Earth truly is, not in a dismissive way, but in a way that is deeply humbling and strangely beautiful. From where you stand right now, Earth feels enormous. It feels endless. You can travel for decades, cross continents, fly over oceans, and still never see all of it. Mountains rise so high they tear through the clouds. Oceans stretch beyond the horizon, swallowing light and distance. Nearly 3/4 of the planet is covered in water, and the land that remains holds deserts, forests, frozen tundra, and cities glowing at night. To a human life, Earth feels vast, solid, and permanent. For most of human history, Earth was not just our home. It was everything. The universe ended at the sky. The stars were lights pinned to a dark dome. The ground felt flat and infinite. And from that perspective, it made perfect sense. The curve of Earth is too subtle to see unless you rise far above it. Stand on a beach, look toward the horizon, and the world feels straight and unbroken. Reality bends quietly beneath perception. Earth measures about 7,926 miles across at the equator. If you could walk around it without stopping, across land and water, at a steady pace of 3 miles per hour, walking 8 hours a day, it would take you just over 3 years to complete the journey. 3 years of nothing but forward motion, one foot after the other, to circle a single planet. That alone tells you something important. From a human point of view, Earth is genuinely big. The planet's total surface area is around 197 million square miles. Imagine trying to visit every square mile, even for just 1 second. No sleep. No breaks. No delays. It would take more than 6 years of continuous travel. And yet, even that astonishing number only reinforces how small our personal experience truly is. Entire lifetimes unfold within a few miles of where we are born. But perspective changes everything. The moment we begin to step back, just a little, the story starts to shift. Earth does not shrink physically. Nothing about it changes at all. What changes is its role. It stops being the center of everything and becomes one object among many. A single point in a much larger structure. Our first step outward brings us to the moon. The moon orbits Earth at an average distance of about 238,855 miles. That distance alone is difficult to grasp. It is roughly equal to driving around Earth's equator more than 9 times. When astronauts traveled there, even with powerful rockets, the journey took about 3 days. And yet, in cosmic terms, this is an incredibly short distance. The moon itself is about 2,159 miles across, roughly a quarter of Earth's diameter. If Earth were the size of a basketball, the moon would be about the size of a tennis ball. Smaller, but not insignificant. What surprises most people is not the moon's size, but its distance. You could line up about 30 Earths side by side between Earth and the moon, and there would still be space left over. Most images you've seen compress this gap, quietly lying to your intuition. That emptiness is real. And it matters. It tells us something fundamental about space. Even here, in our immediate neighborhood, space is mostly nothing. Vast distances separate objects that appear close together when flattened into pictures. The moon feels like a nearby companion, yet it floats alone in a wide ocean of emptiness. Despite that distance, the moon plays a profound role in Earth's story. Its gravity pulls on our oceans, creating tides that rise and fall with steady rhythm. It stabilizes Earth's axial tilt, helping prevent extreme climate swings that could make complex life impossible. The moon is not just nearby. It is quietly essential. There is also a remarkable coincidence written into the sky. The moon appears almost exactly the same size as the sun when viewed from Earth. This happens because the sun is about 400 times larger than the moon, and also about 400 times farther away. That coincidence allows total solar eclipses, moments when the moon perfectly covers the sun, briefly turning day into night. These events feel profound because they are rare alignments in an otherwise indifferent universe. The moon is not fixed in place. Every year, it drifts about 1.5 inches farther away from Earth. Billions of years ago, it was much closer. Back then, days on Earth were far shorter, perhaps only 5 hours long. Time itself felt different because gravity shaped it differently. The slow dance between Earth and Moon continues, silent and inevitable. In 1969, humans stepped onto the Moon's surface. For the first time, a species born on one world touched another. It was a small step physically, but a massive psychological shift. Earth was no longer the only ground we had ever known. And yet, even now, we are still very close to home. To truly understand Earth's scale, we have to look at the sun. The sun dominates our solar system in ways that are almost impossible to overstate. It is about 864,000 miles across, roughly 109 times wider than Earth. In volume, about 1.3 million Earths could fit inside it. Everything that has ever happened on this planet, every ocean, every forest, every civilization, exists on a world that occupies less than 1/1,000,000th of the sun's interior. The sun contains nearly all the mass of the solar system. About 99.86% of it. All the planets, moons, asteroids, and comets combined make up a thin residue by comparison. Earth, which felt so large just moments ago, is now a speck in a sea of fire. The sun sits about 93 million miles away from Earth. Light takes just over 8 minutes to cross that distance. If the sun were to vanish suddenly, Earth would continue orbiting in darkness for more than 8 minutes before the absence even became visible. Cause and effect are separated by distance here. This is the moment where Earth begins to fade, not physically, but conceptually. It is no longer the stage. It is a detail. And this is only the beginning. The sun, for all its power and dominance, is still just a single star. An ordinary one, by cosmic standards. Astronomers classify it as a G-type main sequence star, sometimes casually called a yellow dwarf. It is about 4.6 billion years old, middle-aged. Neither young nor near death. It has enough hydrogen fuel left in its core to shine for another 5 billion years before it begins its slow transformation. Even something as immense as the sun is temporary. Every second, deep within its core, the sun converts roughly 600 million tons of hydrogen into helium. This process, nuclear fusion, releases an astonishing amount of energy. In a single second, the sun produces more energy than all of human civilization has generated throughout its entire history. Every fire ever lit, every engine ever run, every city ever powered is a rounding error compared to the sun's output in a heartbeat. At the surface, the sun burns at around 10,000 degrees Fahrenheit. At its core, where fusion occurs, temperatures reach approximately 27 million degrees. The pressure there is about 260 billion times greater than Earth's atmospheric pressure at sea level. Matter behaves differently under such extremes. Atoms are stripped apart. Reality itself feels stretched. The sun is not calm. It flares. It erupts. Massive loops of plasma arch thousands of miles above its surface, guided by twisted magnetic fields. Occasionally, enormous clouds of charged particles are hurled into space in events known as coronal mass ejections. When these eruptions are aimed at Earth, they collide with our magnetic field, producing shimmering auroras near the poles, curtains of green and purple light dancing across the sky. But these same storms can disrupt satellites, damage power grids, and interfere with communication systems. Even from 93 million miles away, the sun can reach out and touch us. For most of human history, people believed Earth sat at the center of everything. The sun, the moon, the stars, they were thought to orbit us. This idea felt natural. Earth felt still. The heavens moved. It took centuries of observation, argument, and courage for thinkers like Nicholas Copernicus and Galileo Galilei to show that the truth was the opposite. Earth moves. The sun does not orbit us. We orbit it. That realization was humanity's first great lesson in cosmic humility. Once Earth lost its central position, it became possible to see the solar system as it truly is, a structured family of worlds bound together by gravity, all revolving around a single star. Earth is not special because it sits at the center. It is special for other reasons, but scale is not one of them. Let's step outward again. Closest to the sun is Mercury, a small, dense world scarred by craters. It has almost no atmosphere, which means nothing protects it from impacts or moderates its temperature. On Mercury, the surface can reach about 800 degrees Fahrenheit under direct sunlight, then plunge to -290 degrees in darkness. The planet swings between extremes because it cannot hold on to heat. One day on Mercury, from sunrise to sunrise, lasts 176 Earth days. A single sunrise would feel like a lifetime. Next comes Venus, often called Earth's twin because of its similar size. But the resemblance is deceptive. Venus is wrapped in a thick atmosphere of carbon dioxide, with clouds of sulfuric acid drifting through its skies. The pressure at the surface is about 90 times greater than Earth's, equivalent to being thousands of feet underwater. The greenhouse effect there has run completely out of control. Venus's surface temperature hovers around 900 degrees Fahrenheit, hot enough to melt lead. Despite being farther from the sun than Mercury, Venus is hotter. Atmospheres matter. Venus also rotates backward compared to most planets, and it does so very slowly. One day on Venus lasts longer than 1 year there. The sun rises in the west and sets in the east. Time and direction feel inverted. It is a reminder that familiar rules are not universal. Then comes Earth. A narrow band of stability in a hostile environment. Liquid water on the surface. A protective atmosphere. A magnetic field that shields us from solar radiation. A tilt that creates seasons without extremes. Earth does not dominate its neighbors in size or mass. It survives because conditions happen to align just right. Mars follows Earth, smaller and colder, a desert world that once had flowing water. Ancient riverbeds and dried lake basins still scar its surface. Mars lost most of its atmosphere long ago, likely because its magnetic field faded. Without that invisible shield, the solar wind stripped its air away molecule by molecule. Today, Mars averages around -80 degrees Fahrenheit. It is a world caught between what it was and what it became. Beyond Mars lies the asteroid belt, a vast region filled with rocky debris left over from the early solar system. Despite what movies suggest, this region is mostly empty space. The largest object there, Ceres, is only about 588 miles across. You could fly through the asteroid belt and never see an asteroid at all unless you aimed directly at one. Space, even when crowded with objects, is overwhelmingly empty. Then the scale changes dramatically. Jupiter dominates the outer solar system like a monarch. It is about 86,881 miles across, roughly 11 times Earth's diameter. In volume, more than 1,300 Earths could fit inside it. Jupiter contains more mass than all the other planets combined. If it were hollow, every other planet could fit inside with room to spare. And yet, Jupiter is still small compared to the Sun. Jupiter's gravity shapes the solar system. It captures comets. It deflects asteroids. Some scientists believe Jupiter's presence reduced the number of catastrophic impacts Earth experienced, allowing complex life to evolve. In this sense, Earth's story is intertwined with giants far beyond its own size. Saturn follows Jupiter, slightly smaller but visually unforgettable. Its rings, made of ice and rock, stretch tens of thousands of miles from the planet but are astonishingly thin. If Saturn were scaled down to the size of a basketball, its rings would be thinner than a sheet of paper. Beauty here is fragile, balanced on precision. Beyond Saturn are Uranus and Neptune, the ice giants. Both are far larger than Earth, yet small compared to the gas giants. Uranus is tilted on its side, its axis nearly parallel to its orbit. This creates seasons that last decades, with one pole bathed in sunlight for 42 years while the other sits in darkness. Neptune, farther still, hosts the fastest winds ever recorded, reaching speeds of 1,200 miles per hour. These worlds are distant, cold, and violent. Beyond Neptune lies the Kuiper Belt, a vast region of icy objects. Pluto resides here, once considered a planet. Now classified as a dwarf planet. Pluto is only about 1,473 miles across, small enough that several Plutos could line up across Earth's diameter. And even this is not the edge. Far beyond, at distances almost too large to imagine, lies the Oort cloud, a spherical shell of icy debris extending nearly 2 light-years from the Sun. This region marks the true boundary of the solar system. Objects here are barely held by the Sun's gravity. They drift, waiting. Occasionally, one is disturbed and falls inward, becoming a comet, briefly lighting up the inner system before disappearing again into darkness. When you consider the solar system as a whole, Earth becomes something very specific, a small rocky planet orbiting close to a single star, inside a structure that stretches trillions of miles. In a scale model where the Sun is the size of a basketball, Earth would be no larger than a peppercorn, sitting about 26 feet away. And even this enormous model is still tiny compared to what comes next. Because the solar system is not alone. When we leave it behind and venture into interstellar space, distances stop behaving like distances. They become time itself. The nearest star to the Sun, Proxima Centauri, is about 4.24 light-years away. A light-year is the distance light travels in 1 year, nearly 6 trillion miles. Even our closest neighbor is unimaginably distant. If the distance from Earth to the Sun were reduced to 1 inch, the distance to Proxima Centauri would be about 4 miles. Voyager 1, the farthest human-made object, would need more than 70,000 years to reach it at its current speed. And Proxima Centauri is just the beginning. At this scale, Earth does not merely shrink. It disappears. And yet, the universe keeps going. Much farther. Much farther still. At these distances, the idea of travel begins to lose its meaning. Proxima Centauri, our nearest stellar neighbor, sits so far away that even light, nature's ultimate speed limit, needs more than 4 years to cross the gap. And beyond Proxima Centauri lie countless other stars, each separated by oceans of emptiness so vast that the spaces between them matter more than the stars themselves. Proxima Centauri is a red dwarf, the most common type of star in the universe. It is smaller and cooler than the Sun, with a diameter only about 14% as wide. Because it burns its fuel slowly, it will shine for trillions of years. In fact, no red dwarf has ever died of old age. The universe simply hasn't existed long enough. These stars are ancient in patience, outliving entire cosmic eras. But Proxima Centauri is not gentle. It is a flare star, prone to violent outbursts that release intense radiation. Any planet close enough to receive warmth from such a star would also be bombarded by these flares. And yet, Proxima Centauri has planets. One of them orbits in what we call the habitable zone, the region where liquid water could exist. On paper, it sounds promising. In reality, it is likely hostile. Here, even hope must be measured carefully. Beyond Proxima Centauri, the distances only grow. Sirius, the brightest star in Earth's night sky, is about 8.6 light-years away. The light you see from it tonight left that star nearly a decade ago. Betelgeuse, a red supergiant glowing in the constellation Orion, lies roughly 700 light-years away. When you look at it, you are seeing light that began its journey when medieval civilizations still shaped the world. From these distances, Earth is gone. Not hidden. Not small. Gone. Even the sun becomes a single bright point among many. Earth is lost in its glare, far too faint and close to be seen. The entire solar system collapses into a pinprick. Now, take another step outward. All the stars you can see with the naked eye, every single one, belong to the same galaxy, the Milky Way. This vast spiral structure contains somewhere between 100 billion and 400 billion stars. Our Sun is just one among them, orbiting far from the center in a relatively quiet region. The Milky Way stretches about 100,000 light-years across. To put that into perspective, if the distance to Proxima Centauri were reduced to 1 inch, the diameter of the Milky Way would span more than 2,000 feet. Our Sun is located about 26,000 light-years from the galactic center, in a minor arm known as the Orion Spur. We are not in a special place. We are not near the center. We live in the suburbs of the galaxy. At this scale, Earth is no longer a planet. It is no longer even an object. The entire solar system becomes a mathematical abstraction, a point with no dimensions. If the Milky Way were compressed to the size of a 100-foot-wide disk, our entire solar system would be thinner than a human hair. Earth would be smaller than an atom in that model. The Milky Way is not static. It rotates. But not like a solid wheel. Stars closer to the center orbit faster than those farther out. Our Sun completes one orbit around the galactic center every 225 million years. This is known as a galactic year. In the time it takes for the Sun to make one lap, entire species rise and fall on Earth. Continents drift. Climate reshapes the planet. Civilization barely has time to flicker. Earth has completed about 20 galactic years since it formed. The universe itself has existed for roughly 60. The center of the Milky Way is a crowded and violent place. Stars are packed far more densely there than in our region. From a planet near the core, the night sky would never truly be dark. Thousands of stars would blaze overhead, washing the sky in constant light. At the very center sits Sagittarius A*, a supermassive black hole with a mass about 4 million times that of the Sun. All that mass is compressed into a region only a few times larger than the Sun itself. Stars near this black hole orbit at incredible speeds. One known star completes a full orbit in just 16 years, whipping around the center at a significant fraction of the speed of light. Gravity there is no longer gentle. It dominates. Despite its power, the Milky Way is only one galaxy among many. Let's step back again. The Milky Way belongs to a small collection of galaxies, known as the local group. This group contains around 50 known galaxies, bound together by gravity. The largest among them is Andromeda, a massive spiral galaxy containing about 1 trillion stars, more than twice the number in the Milky Way. Andromeda is on a slow collision course with us. In about 4.5 billion years, the two galaxies will merge. this collision will not be catastrophic in the way human intuition imagines. Stars are so far apart that direct collisions are exceedingly rare. Instead, the galaxies will pass through each other, their shapes stretching and distorting under gravity, eventually settling into a single massive elliptical galaxy. By then, the Sun will likely be near the end of its life. Earth, as we know it, will be long gone. The local group spans about 10 million light-years. That sounds enormous, and it is. But it is just a neighborhood. Beyond it lies the Virgo supercluster, a colossal structure spanning roughly 110 million light-years. It contains thousands of galaxies grouped into clusters and filaments. The Virgo cluster itself, located about 54 million light-years away, contains between 1,200 and 2,000 galaxies. Some of these galaxies are far larger and more massive than our own. At the heart of the Virgo cluster lies M87, a giant elliptical galaxy. It contains about 1 trillion stars and hosts a supermassive black hole with a mass 6.5 billion times that of the Sun. This black hole was the first ever directly imaged by humanity. The image revealed a dark shadow surrounded by glowing gas, gravity made visible. If the Milky Way were the size of a coin, the Virgo supercluster would be the size of a city. Everything we have discussed so far, the Sun, Earth, the solar system, the nearest stars, even the Milky Way itself, would fit onto that coin. Earth would be smaller than any grain of dust you could possibly see. But even this is not the end. In 2014, astronomers discovered that the Virgo supercluster is only a part of something even larger. They named it Laniakea, a word meaning, immeasurable heaven. Laniakea is a supercluster of superclusters, containing about 100,000 galaxies spread across 520 million light-years. All of these galaxies, including the Milky Way, are slowly flowing toward a region of intense gravitational pull known as the Great Attractor. The Great Attractor is hidden behind the dust of our own galaxy, invisible in ordinary light. For decades, astronomers knew something massive was there because they could see galaxies moving toward it. Gravity was revealing what light could not. This region is not a single object, but a vast concentration of galaxy clusters pulling everything around them inward. And even Laniakea may not be the largest structure influencing us. Beyond it lies the Shapley supercluster, an even more massive concentration of galaxies located about 650 million light-years away. Its combined gravity appears to be tugging on Laniakea itself. At this scale, words like large and far begin to lose their meaning. Everything becomes motion within motion, structure within structure. Now, imagine compressing all of this, galaxies, superclusters, filaments, down to the size of Earth. The Milky Way would shrink to less than a grain of sand. Earth would vanish entirely, slipping beneath any scale that could be measured. And still, the universe is not finished. Because when we map these galaxies, we see something unexpected. They do not form a random scatter. They form a web. On the largest scales we can observe, the universe reveals a structure both elegant and unsettling. Galaxies are not scattered evenly through space. Instead, they trace vast filaments, stretching hundreds of millions of light-years, weaving together into what scientists call the cosmic web. These filaments intersect at dense nodes, galaxy clusters, while enormous voids, almost completely empty, open between them. This pattern did not emerge by chance. It is the fossil imprint of the universe's earliest moments. Shortly after the Big Bang, tiny fluctuations in density, differences so small they were barely 1 part in 100,000, were stretched by cosmic expansion. Over billions of years, gravity amplified those subtle variations, pulling matter into filaments and knots. What began as faint ripples became the grand architecture of everything. The voids are among the most striking features. Some are hundreds of Millions of light-years across, containing almost nothing at all. Inside them, galaxies are rare. Stars are few. Matter itself seems reluctant to exist. These regions are not completely empty. But they are emptier than anything humans could ever create. If you were placed at the center of one, every direction would look nearly the same, dark, distant, and quiet. And yet, even here, gravity still rules. The universe is expanding, but not in the way an explosion expands into empty space. Space itself is stretching. Every galaxy not gravitationally bound to us is moving away. And the farther away it is, the faster it recedes. This relationship is known as Hubble's law, and it reveals a profound truth: the universe had a beginning. If we run cosmic expansion backward, everything converges. All galaxies approach one another. All distances shrink. Eventually, about 13.8 billion years ago, the universe was in a state of unimaginable density and temperature. Not a point in space, but a point of time. This moment is what we call the Big Bang. At the beginning, the universe was incredibly hot, incredibly dense, and incredibly small. Space and time themselves were compressed. The laws of physics as we know them break down at this boundary. We can describe what happened fractions of a second after the beginning, but the beginning itself remains beyond full understanding. As the universe expanded and cooled, energy condensed into matter. Fundamental particles formed. Quarks bound together to make protons and neutrons. Within minutes, the first atomic nuclei appeared. Hundreds of thousands of years later, electrons joined those nuclei, forming the first atoms. Light, which had previously been trapped in a dense plasma, was finally free to travel. That ancient light still fills the universe today as the cosmic microwave background, a faint glow left over from the dawn of time. From there, gravity took over. Matter slowly gathered into clouds. Those clouds collapsed into the first stars. Inside those stars, nuclear fusion forged heavier elements: carbon, oxygen, iron. When massive stars died, they exploded, scattering those elements into space. Later generations of stars formed from this enriched material. Planets condensed from the leftover debris. Every atom in your body heavier than hydrogen was forged in the heart of a star that lived and died billions of years ago. Earth is made of ancient stardust. Not metaphorically. Literally. From this perspective, Earth is both insignificant and extraordinary. It occupies no special position. It is not central. It is not large. It is not rare in its materials. And yet, on this small world, chemistry crossed a threshold. Matter learned to replicate. To adapt. To remember. Life emerged, and with it, awareness. For nearly 4 billion years, life on Earth remained microscopic. Single-celled organisms dominated the planet, quietly reshaping its atmosphere. Oxygen, once a toxic waste product, accumulated until it became essential. Eventually, complex cells emerged. Then multicellular life. Then brains capable of modeling reality. All of this unfolded on a planet so small that it disappears when viewed from even modest cosmic distances. Consider this: if the entire observable universe were scaled down to the size of Earth, the Milky Way would be smaller than a red blood cell. The solar system would be many orders of magnitude smaller still. Earth would be reduced to something so tiny it defies analogy. And yet, here we are, asking questions about the whole. The observable universe itself spans about 93 billion light-years in diameter. This is not because the universe is only 13.8 billion years old, but because space has been expanding the entire time light has been traveling. Objects we see at the edge of the observable universe emitted their light billions of years ago, when they were much closer. Since then, space itself has stretched, carrying them far beyond where they once were. There are galaxies we can never reach, no matter how fast we travel. They are receding faster than light due to the expansion of space. This does not violate relativity, because nothing is moving through space faster than light. Space itself is expanding. These galaxies will eventually fade from view, slipping beyond our cosmic horizon. The future of the universe is shaped by something we do not fully understand: dark energy. This mysterious component appears to be driving cosmic expansion to accelerate. Over time, galaxies will drift farther apart. Star formation will slow. Eventually, the night sky from any given galaxy will grow darker as distant galaxies vanish beyond the horizon. Trillions of years from now, the universe may enter a state known as heat death, a cold, dilute, and dark cosmos where usable energy is exhausted. Stars will burn out. Black holes will evaporate. Structure will dissolve into randomness. Time will stretch on, but nothing new will happen. Against this backdrop, Earth's entire history is a brief spark. The planet formed about 4.5 billion years ago. Life appeared relatively quickly. Complex life took much longer. Human civilization occupies only the last few thousand years, a fraction so small it barely registers on cosmic timescales. Modern technology, spaceflight, and scientific understanding fit within the last century. And yet, in that sliver of time, we have measured the age of the universe, mapped the cosmic web, photographed black holes, and sent machines beyond the solar system. From a tiny world orbiting an ordinary star, in a quiet corner of a spiral galaxy, we have reached outward with our minds. Earth may be small, but scale does not measure meaning. The universe does not know we are here. It does not care. And that indifference makes our existence more remarkable, not less. On this small planet, in this vast cosmos, matter became curious about itself. And that may be the most extraordinary scale of all. If scale were the only measure of importance, then nothing we do would matter at all. A planet smaller than a speck, orbiting an average star, inside one galaxy among trillions, should be irrelevant. And yet, relevance is not written in size. It emerges from consequence. From awareness. From the fact that, somewhere within this enormous structure, the universe has developed the ability to observe itself. Earth is not impressive because of where it is, or how large it is. Earth is remarkable because of what happened here. From orbit, Earth appears as a thin blue crescent wrapped in a fragile haze. That haze, our atmosphere, is only about 60 miles thick. Compared to Earth's diameter, it is thinner than the skin of an apple. Within this narrow shell exists every cloud, every breath, every ecosystem, every sound ever spoken by a human being. Beyond it lies vacuum, radiation, and silence. This thin layer regulates temperature, circulates water, and shields life from harmful radiation. Without it, Earth would resemble Mars, cold, barren, and silent. The difference between a living world and a dead one can be astonishingly small. Earth's magnetic field, generated by the motion of molten iron deep within its core, extends tens of thousands of miles into space. It deflects charged particles from the sun, protecting the atmosphere from being stripped away. When this field weakens, as it has in the past, radiation increases. Life adapts, or it does not. Nothing is guaranteed. For most of Earth's history, life existed without eyes. Without thoughts. Without names for the stars overhead. And yet, those stars shaped Earth's destiny anyway. Supernova explosions seeded our region of space with heavy elements long before the sun formed. The solar system itself emerged from a collapsing cloud enriched by ancient stellar deaths. Earth's story began before Earth existed. The continents drift slowly across the planet's surface, driven by convection deep within the mantle. Over hundreds of millions of years, they assemble into supercontinents and break apart again. These movements reshape climate, redirect ocean currents, and influence evolution. The rise and fall of species is written not just in biology, but in geology. Mass extinctions have repeatedly reset life's trajectory. Asteroid impacts, volcanic eruptions, climate shifts. At least 5 times, a majority of species vanished in relatively short periods of time. Each time, life rebounded, different, but persistent. Dinosaurs ruled for over 160 million years before a single impact ended their dominance. Mammals, once small and nocturnal, inherited a changed world. Humans arrived extremely late in this story. If Earth's entire history were compressed into a single calendar year, modern humans would appear in the last hour of December 31st, recorded history would occupy the final minute. The industrial age would begin in the last few seconds. In that final blink, we transformed the planet more rapidly than any species before us. We learned to extract energy stored over hundreds of millions of years in fossil fuels. We altered the composition of the atmosphere. We reshaped landscapes, redirected rivers, and pushed countless species toward extinction. From a cosmic perspective, these changes are invisible. From Earth's perspective, they are profound. Our technology has given us a strange dual role. We are both fragile and powerful. Individually, we are vulnerable to heat, cold, radiation, and time. Collectively, we can alter the climate of an entire planet. That contradiction defines our moment in cosmic history. And yet, even with all our power, Earth remains small. Every radio signal ever broadcast, every conversation, every song, every distress call, has been traveling outward at the speed of light. The earliest broadcasts have reached only about 100 light-years into space. That sphere contains a tiny fraction of the Milky Way's stars. The vast majority of the galaxy has no idea we exist. The Voyager spacecraft, launched in 1977, carry golden records bearing sounds and images from Earth. They are drifting through interstellar space, silent messengers from a world that may never be found. In tens of thousands of years, they will pass near other stars. Long after Earth's continents have shifted again, these machines will continue their lonely journey. When Voyager 1 turned its camera back toward Earth from a distance of about 3.7 billion miles, Earth appeared as a pale blue dot suspended in a sunbeam. Every human who ever lived existed on that dot. Every triumph and tragedy. Every war and act of kindness. All of it, contained in a fraction of a pixel. From that vantage point, Earth's scale becomes painfully clear. And yet, so does its value. The universe does not provide meaning. It provides possibility. Meaning emerges when consciousness interprets experience. On Earth, matter arranged itself into forms capable of wonder, of fear, of love, of curiosity. These experiences may be rare. They may be fleeting. But they are real. As far as we know, Earth is the only place in the universe where life has become aware of the universe itself. There may be others. There may be many. Or we may be alone. We do not yet know. But until we do, Earth holds a unique position, not in space, but in awareness. Scale teaches humility. It reminds us that we are not the center. That our planet is not large. That our species is not ancient. But scale also teaches responsibility. On a small world, with limited resources, orbiting an average star in a vast cosmos, there is no backup. No replacement. No second Earth waiting nearby. When you understand how small Earth really is, borders become less meaningful. Divisions feel temporary. The idea of ownership over land, water, or sky begins to feel strange. From space, there are no lines. Only a fragile sphere floating in darkness. The universe will continue expanding whether we survive or not. Galaxies will collide. Stars will be born and die. Black holes will grow and evaporate. None of this depends on us. But the future of Earth does. In the end, the true scale of the universe does not diminish us. It defines us. Because on a planet this small, in a universe this vast, every moment of awareness is precious. Understanding the true scale of the universe does something subtle to the human mind. It doesn't overwhelm all at once. It seeps in slowly, changing the way familiar thoughts feel. The sky is no longer just a backdrop. Night is no longer empty. Distance becomes something deeper than miles or years. It becomes a measure of separation between realities. When you look up at the stars, you are not seeing the present. You are seeing layers of time stacked across space. Some of the light reaching your eyes tonight began its journey before humans existed. Some left its source before Earth even formed. The sky is not a window. It is an archive. This means that the universe we observe is already incomplete. Some stars you see no longer exist. Some galaxies have changed beyond recognition. The farther out you look, the farther back in time you travel. There is no single now across the universe. Each region exists in its own moment, stitched together by the finite speed of light. Earth's present is local. Everything else is history. This realization quietly reshapes the idea of scale. Size alone does not define smallness. Isolation does. Earth is small not only because of its physical dimensions, but because of how disconnected it is from the rest of the cosmos. The vast majority of the universe will never interact with us in any meaningful way. Gravity binds us locally. Beyond that, expansion pulls everything apart. Even within our own galaxy, stars are so far separated that civilizations, if they exist, may never meet. The Milky Way could host millions of inhabited worlds, and they might remain forever unaware of one another. Distance is a barrier stronger than time. And yet, humans persist in reaching outward. We build telescopes that gather light so faint it barely registers above cosmic noise. We place detectors underground to catch elusive particles that pass through Earth by the trillions every second. We listen for signals that may never come. This effort itself is a statement. That understanding matters, even when it changes nothing practical. Consider how much energy is required just to leave Earth. To escape the planet's gravity, an object must reach a speed of about 11.2 kilometers per second. That threshold separates Earthbound from free. Even then, leaving the solar system requires more. Every step outward demands exponentially more energy for diminishing returns. The universe is not designed for travel. It is designed for separation. Relativity enforces this separation with absolute rules. Nothing with mass can reach the speed of light. As an object accelerates closer to that limit, its energy requirement grows without bound. Time slows. Length contracts. Reality itself resists. The universe allows observation, but not easy access. This means that much of the universe will remain forever theoretical. We can measure it, model it, infer its properties. But we will never touch it. Never visit it. Never send a probe that arrives within a meaningful timescale. Knowledge replaces presence. And still, that knowledge changes us. When Earth was first photographed from space, something unexpected happened. People did not respond. Primarily with pride in technology. They responded with vulnerability. Earth looked small. Isolated. Unprotected. That image shifted public consciousness in ways that statistics never could. It helped inspire environmental movements. It reframed political arguments. It made the abstract idea of one world emotionally real. Scale alters values. When you realize that Earth is the only home you will ever know, fragility becomes obvious. The atmosphere cannot be replaced. The oceans cannot be rebuilt. The ecosystems that took billions of years to evolve can be undone in centuries. On a cosmic scale, that is instant. And yet, the universe itself is not fragile. It endures violence beyond imagination. Galaxies collide. Stars explode. Black holes tear matter apart and warp time. On the largest scales, destruction is normal. Stability is rare. Earth exists in a narrow window between chaos and collapse. It is far enough from the galactic center to avoid constant radiation. It orbits a stable star. It has a large moon that moderates its tilt. It possesses liquid water, plate tectonics, and a magnetic field. Remove any one of these factors, and the outcome changes dramatically. Earth is not inevitable. It is contingent. This contingency is what makes scale meaningful. In a universe where vastness is the rule, small, stable pockets become precious. Earth is one of those pockets. Not because it is unique in principle, but because it is unique in fact, to us. From this perspective, the question, how small is Earth, becomes the wrong question. The more important question is, how unlikely is Earth? And the answer is, far more unlikely than our everyday experience suggests. The universe does not trend toward life. It trends toward entropy. Toward disorder. Life is a temporary rebellion against that trend, maintained by energy flow and fragile balance. Earth sits at just the right distance from the sun to sustain that rebellion, for now. Eventually, even that will end. In about 1 billion years, the sun will grow brighter, heating Earth beyond the limits of complex life. Oceans will evaporate. The carbon cycle will fail. Long before the sun becomes a red giant, Earth will be rendered uninhabitable. The planet will continue to orbit, silent and empty. Earth's habitability is not permanent. This knowledge does not diminish the present. It sharpens it. It frames every moment of life as something occurring within a narrow window between cosmic indifference and inevitable change. The universe does not rush. It unfolds over billions of years. Earth's role within it is brief. But during that brief interval, something remarkable is happening. The universe is being understood from within. On this small planet, in this short time, atoms are arranged in a way that allows them to ask questions about their own origin. That is not large in size. But it is vast in implication. And when you step back far enough, beyond planets, beyond stars, beyond galaxies, you begin to see that scale is not about shrinking importance. It is about revealing context. And in that context, Earth is small. But it is not insignificant. When you finally accept the true scale of the universe, something unexpected happens. Fear fades. Not completely, but it changes shape. The cosmos no longer feels like a threat pressing in from all sides. Instead, it feels vast in a quieter way, indifferent, yes, but also neutral. The universe is not hostile. It simply is. Much of human anxiety comes from imagining ourselves at the center of events. When things go wrong, it feels personal. When disaster strikes, it feels targeted. But on a cosmic scale, there is no targeting. Asteroids do not aim. Supernovae do not choose. Gamma-ray bursts do not discriminate. Events unfold according to physics, not intention. This realization can be strangely comforting. Earth has been struck by asteroids before. It will be again. The planet has endured ice ages that covered continents in miles of ice. It has survived periods when nearly all life vanished. Through all of it, Earth continued to orbit. The sun, silent and steady. Life returned, reshaped but persistent. The planet does not panic. It adapts. Human beings, by contrast, are exquisitely sensitive to uncertainty. Our minds evolved to navigate small environments, immediate threats, and short timelines. We are not intuitively equipped to understand millions of years or billions of light years. When we confront these scales, our instincts fail. Only reason carries us forward. That is why the universe feels overwhelming at first. Not because it is cruel, but because it is large beyond intuition. Yet even here, patterns emerge. The same physical laws that govern falling apples govern orbiting planets. The same nuclear reactions that power the sun power distant stars. The same chemistry that allows molecules to form in interstellar clouds allows cells to exist on Earth. The universe is vast, but it is consistent. Complexity arises not from chaos, but from repetition. Earth is a product of that repetition. Carbon atoms forged in dying stars bond in predictable ways. Water molecules behave consistently whether they form oceans or clouds. Gravity pulls matter together wherever it exists. Given enough time and the right conditions, structure emerges. Stars form. Planets form. Chemistry unfolds. Life, then, is not magic. It is physics extended over time. This does not make life less meaningful. It makes it more astonishing. Because while the ingredients are common, the outcomes are not guaranteed. Countless planets may orbit distant stars, but only a fraction will ever host life. Of those, only a fraction may develop complexity. Of those, only a fraction may produce intelligence capable of reflection. Earth sits somewhere along that narrow path. When we talk about Earth being small, we are really talking about probability. About how many ways things could have gone differently. A slightly different orbit. A weaker magnetic field. A nearby supernova at the wrong time. Any of these could have ended Earth's story early. That they did not is not destiny. It is contingency. And contingency creates responsibility. On a planet this small, with no easy escape and no replacement, choices matter. Not on a cosmic scale, nothing we do will alter the fate of galaxies, but on a local one. Earth's future is not written by the universe. It is written by interaction between physics and behavior. This is where perspective becomes practical. When you zoom out far enough, human conflicts shrink. Borders vanish. Ideologies blur. Not because they are meaningless, but because they are temporary. The Earth will outlast them all. What remains uncertain is whether the conditions that support complex life will persist. The irony is sharp. On a planet tiny enough to disappear in cosmic models, we have built systems capable of destabilizing its climate. We have altered atmospheric chemistry in a geological instant. We have become a force comparable to volcanic activity or asteroid impacts, not through malice, but through scale multiplied by time. This is not a moral judgment. It is an observation. From the universe's perspective, Earth warming or cooling is irrelevant. Life emerging or vanishing is routine. From our perspective, it is everything. Perspective does not tell us what to value. It tells us what is rare. And on the scale of the universe, stable, life-bearing planets are rare. This does not mean humanity must expand into space to matter. Space colonization may happen. It may not. Even if it does, Earth will remain foundational. Every culture, every language, every idea that leaves this planet will carry its imprint. Earth is the reference point from which all future exploration begins. No matter how far we travel, Earth will always be home zero. The true scale of the universe also reframes time. Civilizations feel ancient when they span thousands of years. Empires feel permanent until they collapse. But the universe measures time in billions of years. From that perspective, human history is a flicker, bright, brief, and easily missed. That does not make it meaningless. A spark can illuminate darkness even if it lasts only a moment. On this small planet, during this brief window, consciousness exists. It wonders. It doubts. It imagines futures that may never arrive. That capacity did not have to emerge. It is not required by physics. It is an outcome, not a rule. The universe does not demand that it be understood. But here, on Earth, it is. And that is why size alone cannot define importance. Earth is small in space. Small in time. Small in mass. But within that smallness, something unprecedented is happening. The universe is becoming aware of its own scale. There is a quiet paradox at the heart of all this. The more clearly we understand how vast the universe is, the more sharply Earth comes into focus. Not as a place of dominance or centrality, but as a point of concentration. A place where complexity gathered long enough to become self-aware. In a universe measured in billions of light years, meaning does not scale with size. It scales with experience. Earth is small because it must be. Large planets tend to become gas giants, hostile to solid surfaces and stable chemistry. Large stars burn fast and die young. Large galaxies are violent, crowded, and radiation-filled. Small, stable systems are where complexity has time to unfold. In that sense, smallness is not a flaw. It is a requirement. Our sun is not massive. That is why it will shine steadily for billions of years instead of exploding in a few million. Earth is not large. That is why its gravity is strong. Enough to hold an atmosphere, but weak enough to allow geological recycling through plate tectonics. Even our moon's size, relative to Earth, is unusual, and that unusual balance stabilizes our climate. Everything about Earth's scale seems tuned for duration rather than spectacle. The universe, by contrast, is spectacular but fleeting in its structures. Stars are born and die. Galaxies collide and distort. Entire clusters shift under gravity's slow pull. Stability is local and temporary. Earth exists within one of those rare pockets where change happens slowly enough for memory to form. Memory is the key difference. Rocks remember through layers. Ice remembers through trapped air bubbles. Trees remember through rings. Life remembers through DNA. Humans remember through stories, records, and symbols. On Earth, the universe has developed a way to preserve information across generations. That alone sets this planet apart, not in location, but in function. Consider how improbable it is that you are able to think about scale at all. The atoms in your body were once scattered across interstellar space. Gravity gathered them. Chemistry organized them. Biology arranged them into cells, tissues, and neural networks capable of abstraction. Now those atoms are temporarily aligned in a way that allows them to imagine galaxies they will never see directly. This is not poetic exaggeration. It is literal. And it is temporary. In a few decades, the specific configuration that is, you, will dissolve. The atoms will persist, recycled into Earth's systems. Eventually, they will be scattered again when the sun expands and sheds its outer layers. On cosmic timescales, individual lives are negligible. But patterns persist longer than individuals. Civilizations may last thousands of years. Species may last millions. Planets may remain habitable for billions. Each layer adds time, but none are permanent. The universe trends toward Dispersion. Complexity must continually fight that trend to survive. That fight is happening right now on Earth. The smallness of Earth means feedback is immediate. Pollute the atmosphere, and the climate responds. Remove forests, and ecosystems unravel. Acidify oceans, and food chains collapse. On larger scales, consequences take longer to propagate. On Earth, everything is close. Enough to matter quickly. This is what scale teaches most clearly: proximity creates responsibility. There is nowhere on Earth that is truly far away. A particle released into the air does not respect borders. Heat trapped in the atmosphere does not localize itself. Water circulates globally. Earth behaves as a single system because it is one. From space, this is obvious. From the ground, it is easy to forget. The universe offers no guidance here. It does not reward preservation or punish destruction. Stars do not care if planets live or die. Black holes do not register the difference between silence and song. Meaning arises locally, or not at all. That places Earth in a rare position. It is a small world where meaning exists because minds exist to create it. When astronomers search for life beyond Earth, they do not look for intelligence first. They look for atmospheres out of equilibrium. Oxygen coexisting with methane. Chemical signatures that should not persist unless something is actively maintaining them. Life leaves fingerprints on a planet. Earth's atmosphere is one of those fingerprints. For billions of years, life has been shaping this planet, quietly and relentlessly. Oxygen levels rose. Ozone formed. Climate stabilized within narrow bounds. Earth's surface is not natural in the cosmic sense. It is biological. That means Earth's smallness is deceptive. It is not an inert rock drifting through space. It is an active process. A system constantly adjusting itself within tight limits. Few places in the universe do that. When you compare Earth to the vastness around it, it is easy to feel insignificant. But insignificance is not the same as irrelevance. A single neuron is small compared to the brain, yet remove it, and the system changes. Earth is small compared to the universe, but it is one of the few places where the universe is being reflected upon. The cosmic web does not think. Galaxies do not wonder. Stars do not remember. Earth does. That does not grant it cosmic privilege. It grants it local importance. In the end, the question, how small is Earth, has a precise scientific answer. We can measure its radius, mass, volume, and position. We can compare it to stars, galaxies, and the observable universe. By every physical metric, Earth is tiny. But the deeper answer is not numerical. Earth is small enough to be fragile. Small enough to be shaped by life. Small enough that choices matter. And in a universe where almost everything is too large, too violent, or too empty for that to be true, smallness is not a weakness. It is the condition that made everything else possible. There is one final shift that happens when scale fully settles in. It is not dramatic. It does not arrive with awe or fear. It arrives quietly, as acceptance. You stop trying to imagine the universe as something built for you. And in doing so, you begin to see your place within it more clearly. The universe does not revolve around Earth. It never did. Earth is not the destination of cosmic evolution, nor its goal. There is no narrative arc written into space-time that ends with humanity. The universe is not a story with us as the main character. And yet, here we are, inside it. That is the part that matters. Earth exists at the intersection of chance and law. Physical constants have specific values. Gravity behaves the way it does. Electromagnetism allows chemistry to exist. Nuclear forces hold atoms together. None of these rules were written with planets or life in mind. And yet, under those rules, Earth formed. The planet did not need to be here. Life did not need to emerge. Consciousness did not need to awaken. But they did. When you step back far enough, you begin to see that rarity is not about size or distance. It is about conditions aligning long enough for complexity to persist. Most of the universe is either too hot, too cold, too empty, or too unstable. Earth sits in a narrow band between extremes. Not perfect. Not permanent. Just sufficient. This reframes what small actually means. Earth is small in volume, but dense in consequence. Small in mass, but rich in process. Small in duration, but layered with history. Every mountain is a record of pressure and time. Every fossil is a memory of a vanished world. Every culture is an experiment in cooperation under constraints. All of it happens on a sphere that could vanish entirely if you zoom out far enough. This is why scale is not nihilistic. It is clarifying. It strips away illusions of permanence and replaces them with awareness of limits. It reveals that what matters most happens locally, not cosmically. The universe provides the stage. Earth hosts the play. And the play is fragile. The future of Earth is not written in the stars. It is written in feedback loops, decisions, and delays. Climate systems respond. Slowly, then suddenly. Ecosystems collapse quietly, then all at once. On a small planet, thresholds matter. Scale makes this unavoidable. There is no external reset button. No cosmic intervention. No larger system stepping in to correct mistakes. Earth is a closed experiment with limited margins. And yet, within those margins, there is beauty. There is music created by vibrating air. Molecules. There are images formed by reflected light. There are ideas that exist only because neurons fire in coordinated patterns. There is empathy, memory, regret, hope. None of these register on a cosmic map. None of them bend galaxies or alter expansion. But they exist here. On Earth. When astronauts describe the overview effect, the psychological shift experienced when seeing Earth from space, they rarely talk about size alone. They talk about unity. About fragility. About how artificial divisions feel from a distance. Scale collapses ego. Distance dissolves borders. The universe does not ask us to matter to it. It asks nothing at all. Meaning is something we generate locally, or it does not exist. And Earth is one of the few known places where that generation is happening. This does not mean Earth must last forever to matter. A poem does not need to be infinite to be meaningful. A life does not need to be eternal to be valuable. Duration amplifies impact, but it does not define it. Earth's value lies in what occurs here, not how long it persists. In the far future, when Earth is uninhabitable, when the sun swells and sheds its outer layers, when the planet becomes a scorched remnant orbiting a dying star, the universe will continue without noticing. That indifference does not erase what came before. It simply places it in context. Earth was small. Earth was brief. Earth was alive. And for a time, on this small world, the universe was understood by something that emerged from it. That understanding did not change the cosmos. It changed us. Which brings us to the quiet conclusion that scale offers. You do not need to be large to matter. You do not need to be central to be significant. You do not need to be permanent to be real. Earth proves this. A tiny planet. Orbiting an ordinary star. In a vast, expanding universe. And yet, within that smallness, everything we have ever Known has happened. That is the true scale of Earth. Not measured against galaxies or voids, but measured against the fact that, here, the universe became aware of itself. There is a temptation, once you reach this understanding, to stop there. To let the conclusion settle and walk away with a sense of closure. But the true scale of the universe does not really end in a conclusion. It lingers. It keeps unfolding long after the facts are understood. Because scale is not something you learn once. It is something you live with. Every ordinary moment on Earth carries a hidden dimension of scale. When you breathe, the oxygen entering your lungs was forged in ancient stars. When sunlight warms your skin, those photons began their journey 8 minutes earlier at the sun's core. When you drink water, the molecules in that glass may have passed through glaciers, oceans, clouds, dinosaurs, and countless living beings over billions of years. Nothing here is truly new. Nothing here is isolated. Earth is small, but it is deeply connected. This is what often gets lost when we talk about cosmic vastness. Distance suggests separation, but physics tells a different story. The same constants apply everywhere. The same equations describe motion on Earth and motion between galaxies. The universe is not fragmented, it is continuous. Earth is part of that continuity. The atoms in your body obey the same laws as the atoms in a distant quasar. The difference is arrangement, not substance. Complexity emerges when matter has time and stability. Earth provided both. That makes this planet not a footnote, but a chapter. A short one, perhaps, but dense. Consider how much information exists on Earth right now. Languages spoken. Stories remembered. Scientific knowledge accumulated. Art created. Relationships formed. Every one of these represents structure layered on top of structure, patterns built upon patterns. None of that violates physics. None of it is inevitable. It happens because Earth is small enough for feedback to matter, and stable enough for memory to persist. In a galaxy where stars are separated by light years, interactions are rare. On Earth, everything interacts constantly. Atmosphere meets ocean. Life alters geology. Intelligence alters ecosystems. Cause and effect are tightly coupled. That tight coupling is what allows complexity to accelerate. Scale enables this acceleration. If Earth were much larger, gravity would crush delicate structures. If it were much smaller, it would lose its atmosphere and heat. If time moved faster here, evolution would stall. If it moved slower, complexity might never converge. Earth exists at a scale where change is possible without being overwhelming. That balance is extraordinary. When people imagine significance, they often imagine size. Bigger monuments. Larger empires. Expanding influence. But the universe suggests a different metric. What matters is not how much space something occupies, but how much structure it sustains. A black hole can outweigh billions of stars, yet it contains almost no internal complexity. A living cell weighs almost nothing, yet it sustains chemical processes so intricate they rival anything else we know. Earth is closer to the cell than the black hole. Its smallness allows gradients of temperature, pressure, chemistry, energy, to exist side by side. Those gradients drive motion. Motion drives change. Change drives adaptation. Adaptation drives awareness. This chain does not scale indefinitely. It only works in narrow windows. That is why Earth feels special without being central. And that is why understanding scale changes how you see your own life. Your lifespan is short compared to civilizations. Civilizations are brief compared to species. Species are fleeting compared to planets. Planets are temporary compared to stars. Stars are transient compared to galaxies. Galaxies are momentary compared to the universe. And yet, meaning does not vanish as scale increases. It condenses as scale decreases. Your thoughts matter because they exist at a scale where experience is possible. Your actions matter because they propagate through systems close enough to respond. On Earth, small causes can have large effects. Precisely because everything is near. The universe is too large for that. Earth is not. This is the final lesson scale offers. The universe teaches humility by showing us how small we are. Earth teaches responsibility by showing us how much we can affect. Both lessons are true at the same time. When you look back at Earth from the edge of imagination, past planets, stars, galaxies, and cosmic filaments, it disappears. It becomes nothing. But when you look at the universe from Earth, it becomes knowable. Not fully. Not completely. But enough to ask questions. That asymmetry matters. Earth does not need the universe to be meaningful. The universe, as far as we know, needs places like Earth to be understood. If there are other worlds like this, and there may be many, then they too carry this burden and this gift. Small islands of awareness scattered across an expanding sea. None of them central. All of them rare. Until we know otherwise, Earth is one of them. A small world. A brief moment. A fragile system. But within it, something extraordinary has occurred. The universe has looked back at itself, measured its own scale, and wondered what it means. That wondering does not echo across galaxies. It does not bend space-time. It does not alter expansion. But it exists. Here. On Earth. And that is enough. At this point, there is nothing left to add in terms of distance. No farther place to travel. No larger structure to reveal. We have stepped beyond planets, beyond stars, beyond galaxies, beyond even the largest patterns the universe presents to us. What remains is not scale, but understanding. Because once you have gone far enough, scale stops being about how big and becomes about how related. The universe is vast. But it is not fragmented. Everything that exists is part of a single unfolding process. Space, time, matter, and energy are not separate categories, they are different expressions of the same underlying reality. Earth is not outside that reality, and neither are you. From the moment the universe began expanding, every particle has been in motion. Every atom carries a history. Every location carries the imprint of everything that has passed through it. Earth is small, but it is not isolated from this story. It is deeply embedded in it. What makes Earth stand out is not its position or its size, but its timing. We exist during a brief era when stars are still forming, when heavy elements are abundant, when energy gradients are strong enough to support complexity. Too early in the universe's history, and there were no planets. Too late, and stars will have burned out. Earth exists in a narrow temporal window where the universe is neither too young nor too old for life to flourish. This window will close. In the distant future, star formation will cease. Galaxies will grow dim. The universe will become colder, darker, and simpler. Complexity will be harder to sustain. Awareness, if it exists at all, will be rare and isolated. Earth exists before that decline. That fact alone gives the present an unusual weight. When we ask how small Earth is, we often expect the answer to humble us into silence. But true humility does not erase responsibility, it clarifies it. On a planet this small, during a moment this brief, the fact that anything can be experienced at all becomes remarkable. You are not separate from Earth's smallness. You are an expression of it. Your body is tuned to this planet's gravity. Your senses evolved under this sun's light. Your biology depends on this atmosphere's chemistry. Your thoughts arise from patterns shaped by Earth's history. If Earth were different, you would not exist in any recognizable form. And that is not a limitation. It is a context. The universe does not offer infinite chances for this kind of emergence. It does not endlessly generate worlds like Earth on demand. It produces them rarely, under specific conditions, and then moves on. Earth is one such outcome, neither guaranteed nor repeatable in detail. That makes it fragile. But fragility is not insignificance. A crystal is fragile. A melody is fragile. A moment of understanding is fragile. Their value lies precisely in the fact that they can be lost. Earth's smallness means it can be damaged. It also means it can be cared for. On a cosmic scale, no action we take will echo far. We will not alter the expansion of the universe. We will not change the fate of galaxies. But on Earth's scale, actions compound. Feedback loops respond. Systems shift. This is the scale at which agency exists. The universe does not grant agency at large scales. Atoms do not choose. Stars do not decide. Galaxies do not reflect. Agency emerges only where complexity is dense enough and timescales are short enough for cause and effect to meet. Earth is one of those places. That is why Earth feels heavy with consequence despite being light in mass. That is why human decisions matter locally even though they vanish cosmically. Meaning lives where response is possible. The final insight scale offers is this. You do not need the universe to care for something to matter. You only need it to be rare, contingent, and experienced. Earth meets all three. It is rare enough to be precious. Contingent enough to be fragile. Experienced enough to be meaningful. When you truly grasp how small Earth is, the question stops being, what is our place in the universe, and becomes, what kind of moment is this? This moment, when Earth is alive, when awareness exists, when the universe is still bright enough to be seen, is temporary. It will pass. But while it lasts, it contains everything we have ever known. That does not diminish it. It defines it. Earth does not need to be large to matter. It needs to be lived. And it is. Right now. Eventually, every exploration reaches a point where moving farther no longer reveals something new, but instead returns you to where you began, changed. That is where this journey ends. Not at the edge of the universe, but back at Earth, seen clearly at last. When you first hear how small Earth is, the reaction is often disbelief. It feels abstract. Numbers fail. Light years blur together. Galaxies become concepts rather than places. But once the idea settles, it changes the weight of ordinary things. A sunrise is no longer just a daily event. It is a precise alignment between a small planet and an ordinary star, occurring within a narrow window of cosmic conditions that will not last forever. Rain is not just weather. It is the movement of ancient water molecules, cycling through a thin atmosphere that should not exist, but does. Life is not just common behavior. It is an unlikely chemical persistence against entropy. Earth is small enough that all of this happens close together. That closeness is everything. On larger scales, change is slow and indifferent. On Earth, change is intimate. Forests respond within decades. Oceans respond within centuries. Climate responds within generations. Feedback is immediate enough to be felt, remembered, and acted upon. That is not true on the scale of stars or galaxies. Earth operates at the scale where consequences are visible. This is why perspective matters so much. When you lose sight of scale, it is easy to believe that growth can be infinite, that resources are endless. That damage is reversible. But the universe tells a different story. It shows us that stability is rare, that balance is temporary, and that complexity survives only within narrow bounds. Earth sits inside those bounds. For billions of years, it has maintained them, not perfectly, not permanently, but long enough for something extraordinary to happen. Life learned not only to survive, but to reflect. To ask where it came from. To measure the stars. To build instruments capable of seeing across time itself. All of that arose on a planet that vanishes when viewed from the wrong distance. This is not a contradiction. It is a lesson. Scale teaches that importance is not assigned from above. It emerges from within. The universe does not designate special places. It allows conditions. What happens next depends on how those conditions are used. Earth is not protected by its size. It is not preserved by its rarity. It is not guaranteed by physics. Its future depends on behavior occurring right now, on a small world, among a species that has only recently become aware of the consequences of its own actions. That awareness is new. It is fragile. And it matters. Because awareness changes the nature of responsibility. To know how small Earth is, and to act as if it is infinite, is ignorance. To know how small Earth is, and to act with care, is maturity. The universe will not reward that maturity. It will not punish its absence. It will simply continue. Earth will not. That is the final clarity scale brings. Not despair. Not insignificance. But focus. This planet does not need to compete with the universe. It only needs to sustain what happens here. A thin atmosphere. Liquid water. A stable orbit. A web of life. A network of minds capable of understanding all of this. From far enough away, Earth is nothing. From close enough, it is everything. Both views are true. But only one allows choice. And choice exists only here. On a small planet. At a brief moment. In a vast universe that will never notice either. Earth is small. That is why it matters. What remains, after everything has been said, is not another fact, or another comparison, or another unimaginable distance. What remains is a way of seeing. Because once you truly internalize how small Earth is, you cannot unknow it. It subtly rewires how the world feels. Not louder. Not dramatic. Just clearer. The sky no longer feels like a ceiling. The ground no longer feels permanent. Time no longer feels abundant. And yet, life feels sharper. Every generation before us lived without knowing the universe at this scale. They saw stars, but not galaxies. They imagined heavens, but not cosmic webs. They felt awe, but not context. We are among the first humans to know, really know, where we are. That knowledge is heavy. Not because it demands despair, but because it removes excuses. We can no longer claim ignorance of limits. We can no longer pretend that Earth is endlessly forgiving. We can no longer act as if consequences disappear somewhere out there. There is no out there for Earth. The universe gives us no safety net. No rewind. No alternative timeline. What happens on this planet stays on this planet, written into its chemistry, its biology, its climate. On a cosmic scale, nothing erases those marks. This is what it means to live on a small world. Small worlds amplify responsibility because everything is connected. Oceans talk to the atmosphere. Ice talks to sunlight. Forests talk to rainfall. Life talks to geology. And now, intelligence talks to all of it at once. That is new. Never before has a species understood the full scale of the system it inhabits while also possessing the power to alter it. That combination is rare enough to feel almost unstable. Awareness arrived faster than wisdom. Capability arrived faster than restraint. Whether those catch up remains to be seen. But scale offers guidance, if we listen. It tells us that permanence is an illusion. That dominance is temporary. That cooperation outlasts conquest. That balance is more powerful than growth. It tells us that small systems collapse quickly when pushed too hard, and recover slowly when damaged deeply. It tells us that resilience comes from diversity, not uniformity. From redundancy, not efficiency alone. Earth already knows this. Life learned it long before we did. The question now is whether intelligence will learn it in time. From far away, farther than any human will ever travel, Earth would be invisible. Not hidden. Not dim. Simply too small to register. No signposts. No markers. No announcement that something extraordinary is happening here. And yet, here, right now, it is. Children are being born. Ideas are being shared. Mistakes are being made. Beauty is being created. Understanding is slowly expanding. None of this matters to the universe. All of it matters to Earth. That contrast is not tragic. It is grounding. The universe sets the boundaries. Earth fills them with meaning. When you understand the true scale of the universe, you stop asking it to care about you. You stop expecting validation from size or permanence or destiny. Instead, you turn your attention to the only scale where care actually operates. This one. The human scale. The planetary scale. The scale where actions echo. The scale where memory persists. The scale where loss is felt. The scale where protection is possible. Earth is small enough to be harmed. Small enough to be healed. Small enough that attention matters. And that is the final truth hidden inside all the vastness. The universe is enormous, but indifferent. Earth is tiny, but responsive. One offers perspective. The other offers consequence. And we live at the intersection of both. A small planet, orbiting an ordinary star. Inside a galaxy that will one day fade. In a universe that will never notice. Yet here, for this brief moment, everything that can be noticed is. There is nothing beyond. This that expands outward. Only something that settles inward. Because once you reach the end of scale, you are left with proximity. You are here. On Earth. Now. The universe does not rush you to understand it. It unfolds at its own pace, indifferent to comprehension. Stars will continue burning whether they are studied or ignored. Galaxies will continue drifting whether they are named or not. The cosmic web will stretch and thin whether it is mapped or forgotten. Understanding is not required. But it happens anyway, here. Earth is small enough that understanding matters to the system itself. Knowledge feeds behavior. Behavior feeds outcomes. Outcomes loop back into conditions. On this planet, awareness is not passive. It changes trajectories. That is rare. Most matter in the universe will never know what it is doing. Most energy will never reflect on its own motion. Most structures will form, dissolve, and vanish without ever being noticed by anything capable of noticing. Earth broke that pattern. For a brief interval, matter here organized into minds that could ask where they were, how big it all was, and what it meant. Those questions do not alter the expansion rate of the universe. They do not change the fate of stars. But they do alter what happens next on this planet. Scale makes that clear. If Earth were larger, consequences would be slower. If it were smaller, stability would be harder. If it were farther from its star, chemistry would freeze. If it were closer, complexity would burn. Earth exists at a scale where choice has leverage. That leverage is easy to underestimate because it feels ordinary. The ground feels solid. The sky feels endless. Days feel repetitive. But from far enough away, farther than any image can truly convey, this world is a brief, delicate configuration that could easily tip into something far simpler. Silence is the default state of the universe. Earth is an exception. Not an eternal one. Not a guaranteed one. Just a real one. The true scale of the universe does not ask you to feel small. It asks you to feel precise. To understand that this moment is narrow. That this system is sensitive. That this planet is finite. And that within those limits, everything that matters to you is happening. There is no larger stage waiting to replace this one. No cosmic archive that preserves meaning by default. No external witness to validate what unfolds here. Earth does not need the universe's attention. It needs ours. Because size does not protect a thing. Awareness does. The universe will remain vast whether Earth thrives or fails. But Earth's future will be shaped by whether those who understand its smallness act accordingly. That is where scale ultimately points, not outward, but inward. To attention. To restraint. To care. A small planet does not survive by being impressive. It survives by being understood. And for the first time in its long history, Earth is. That understanding is fragile. But it exists. Here. Now. On a world small enough that it still matters. At the very end of this journey, nothing explodes into revelation. There is no final twist, no sudden expansion, no last distance to cross. What remains is a stillness that feels earned. Because the true scale of the universe does not end with awe. It ends with clarity. Earth does not become smaller the more we learn. Our illusions about it do. We lose the illusion that it is endless. We lose the illusion that damage disperses harmlessly. We lose the illusion that time will always be available later. What replaces those illusions is not fear, but precision. This planet is not large enough to absorb infinite mistakes. Not resilient enough to ignore cumulative change. Not distant enough for consequences to fade away. And yet, it is resilient enough to respond. Flexible enough to recover. Alive enough to heal, if given the chance. That balance exists only at this scale. The universe is too large for repair. Too vast for correction. Too indifferent for care. Earth is not. Here, cause and effect meet within a lifetime. Here, actions leave signatures that persist. Here, understanding can still redirect outcomes. That is what makes this planet unusual, not its place in space, but its position in responsibility. When you understand how small Earth truly is, you stop expecting salvation from distance. You stop believing that escape will solve what attention avoids. You realize that survival is not about reaching farther, but about living better where you already are. The future does not depend on conquering the stars. It depends on stabilizing this world. Because no matter how far intelligence may travel one day, it will always trace its origin back to a small blue planet that learned, briefly, to understand itself. Earth is where complexity crossed into awareness. Where matter learned to remember. Where the universe became observable from within. That does not make Earth central. It makes it consequential. And consequence only exists at this scale. Too small for indifference. Too connected for denial. Too fragile for neglect. The universe will not mourn if Earth falls silent. But Earth will. And everything that has ever mattered to us exists within that difference. So when you ask how small Earth really is, the most honest answer is this. It is small enough that everything is at stake. Small enough that care still works. Small enough that understanding still matters. In a universe so large it erases meaning by distance. Earth concentrates it. A tiny planet. A thin atmosphere. A brief window of time. And within it, a chance, rare, contingent, and real, to choose what happens next. That is not a cosmic story. It is a planetary one. And it is still being written. When everything is finally reduced to its simplest form, scale leaves behind one quiet truth: nothing about Earth is guaranteed. Not its climate. Not its biodiversity. Not its civilizations. Not even its habitability. Stability here is not the default state. It is something that must be continuously maintained. Often without being noticed. The atmosphere stays breathable because countless processes remain in balance. Oceans stay liquid because temperature sits within a narrow range. Life persists because feedback loops correct excess before it becomes collapse, until they don't. The universe does not offer this kind of balance. It does not hover at the edge of habitability. It moves decisively toward extremes. Toward cold or heat. Toward dispersion or collapse. Earth exists between those endpoints, not because it was designed to, but because conditions happen to align, and continue aligning, for now. This, for now, is the most honest phrase in cosmology. Stars shine for billions of years, but not forever. Planets remain stable for eons, but not indefinitely. Life adapts for long stretches. But not without limits. Earth's smallness means those limits are reachable. That is why scale ultimately becomes ethical, not abstract. On a large enough stage, individual actions dissolve into insignificance. On Earth, they do not. Energy choices alter atmospheric chemistry. Land use reshapes ecosystems. Technology amplifies intention faster than biology can adapt. The tighter the system, the stronger the consequences. Earth is tight. This is not a flaw. It is what allowed intelligence to emerge at all. But intelligence without awareness of scale becomes destabilizing. Power outpaces understanding. Capability outruns restraint. History shows this pattern repeatedly, on smaller scales, in smaller systems. Now it plays out on a planetary one. Understanding the true scale of the universe does not demand pessimism. It demands calibration. It teaches that progress must fit within limits, not attempt to erase them. That survival is not expansion without end. But balance maintained long enough for meaning to persist. The universe is not a ladder we climb. It is a landscape we navigate. Earth is one small clearing within that landscape where navigation is possible. Everything we value, art, science, memory, relationships, wonder, depends on this clearing remaining intact. There is no redundancy built into the system. No duplicate Earth waiting elsewhere. Even if similar planets exist, they are unreachable within meaningful time. This one carries all continuity we know. That is the weight of smallness. Not despair. Not insignificance. But concentration. When you zoom out far enough, Earth disappears. When you zoom in far enough, everything that matters appears. Both perspectives are true. Wisdom lives in holding them together. The universe teaches humility by scale. Earth teaches responsibility by proximity. And between those two lessons lies the only place where choice exists. Here. On a planet small enough to be lost among galaxies. Yet intimate enough that every decision still counts. That is how small Earth really is. Small enough that it can be damaged. Small enough that it can be protected. Small enough that attention is not optional. And large enough. Just barely large enough. To hold awareness, memory, and care. For a brief, extraordinary moment. In an otherwise silent universe. There is no grand finale waiting beyond this point. No final revelation hidden behind one more layer of distance. What remains is not expansion, but return. Return to the small. Because once the universe has been fully stretched across your imagination, once Earth has been reduced to a vanishing point among galaxies, the only meaningful move left is inward, back to the scale where experience actually occurs. Back to Earth. The universe is impressive because it is vast. Earth is important because it is finite. Those two qualities do not compete. They define different kinds of truth. The universe teaches us what exists. Earth teaches us what can be sustained. On the largest scales, there is no urgency. Galaxies take billions of years to change shape. Cosmic expansion unfolds. Patiently, indifferent to milestones. Nothing is in a hurry because nothing needs to be. Earth is different. Here, timing matters. Delays matter. Feedback matters. Miss a threshold. And systems do not politely rewind. They shift into new states that may not support what came before. On a small planet, transitions are not theoretical. They are lived. This is why understanding scale is not an intellectual luxury. It is a practical necessity. Without scale, power feels abstract. Without scale, damage feels reversible. Without scale, limits feel negotiable. But the universe does not negotiate with limits. It enforces them quietly, consistently, without intent. Earth exists within those limits. The thinness of the atmosphere is not symbolic. It is physical. The oceans do not contain infinite buffering capacity. Forests do not regenerate instantly. Biodiversity does not reassemble itself once lost. These are not moral arguments. They are properties of small systems. And Earth is a small system. The extraordinary thing is not that Earth is vulnerable. It is that it has lasted as long as it has. 4.5 billion years. Of balance, adjustment, and recovery. 4.5 billion years of near misses and narrow escapes. 4.5 billion years without guarantees. That history does not promise a future. But it explains the present. We live at a moment when Earth is still complex, still alive, still capable of supporting awareness. That is not the default state of planets. It is a temporary configuration, maintained by processes that require care, whether intentional or not. For most of Earth's past, that care came from blind feedback loops. Biology adjusted to climate. Climate adjusted to geology. Systems responded automatically. Intelligence was not required. Now it is. For the first time, a single species understands both the fragility of the system and its own ability to disrupt it. That combination is new. There is no precedent for it in Earth's history. There is no cosmic manual explaining how it resolves. Scale does not tell us what will happen next. It tells us what is possible. It shows that collapse is easy. That recovery is slow. That prevention is subtle and unglamorous. It shows that the universe will not intervene. And that Earth will respond regardless. This is where the idea of smallness becomes decisive. On a planet this small, care is not optional. It is structural. Ignore enough signals, and the system shifts. Act early enough, and it stabilizes. There is no heroic scale at which solutions suddenly become effortless. There is only alignment with limits. That is not a burden imposed by the universe. It is a condition created by scale. And within that condition, meaning is concentrated. Not because Earth is special in the cosmic sense, but because it is special in the experiential one. It is the only place where your memories exist. Where your relationships exist. Where your understanding exists. Where anything you have ever valued has taken shape. The universe is vast enough to erase all of that without noticing. Earth is small enough that it still depends on it. That asymmetry is not tragic. It is clarifying. It tells you exactly where attention belongs. Not in competing with galaxies. Not in seeking permanence. Not in demanding cosmic significance. But in sustaining this brief, delicate arrangement where experience is possible at all. Earth does not need to be eternal to matter. It needs to be intact long enough for care to continue. And that is still possible. Right now. This is the final truth scale leaves behind. The universe is too large to hold meaning. Earth is small enough to contain it. A fragile sphere. A thin layer of life. A narrow window of time. And within it, everything you have ever been. Everything you have ever known. Everything you have ever hoped for. That is how small Earth really is. And that is why it matters. At this point, continuation no longer means adding distance or argument. It means allowing the perspective to settle into something usable. Because the true scale of the universe is not meant to impress you forever. It is meant to recalibrate you. Once that recalibration happens, the universe stops feeling like something out there and starts feeling like the background condition of everything you do. It becomes the silent frame that gives proportion to effort, loss, ambition, and care. You begin to notice how strange it is that meaning survives at all. On a planet so small it disappears when viewed correctly, entire inner worlds exist. Joy and grief. Hope and regret. Love and fear. These are not cosmic forces. They do not bend space-time. They do not travel light years. And yet, they shape lives completely. Scale reveals that the most powerful things on Earth are not the largest ones. They are the ones that propagate locally, through proximity. A word can change a life. A decision can alter a future. A generation can redirect a planet. None of this would be possible on a larger world with slower feedback and weaker coupling. Earth's smallness compresses consequence. It makes cause and effect visible enough to matter. This is why the universe feels cold and Earth feels intimate. The universe is governed by laws. Earth is governed by relationships. Gravity binds galaxies. Relationships bind meaning. And meaning only exists where scale allows memory, response, and care to overlap. That overlap is rare. When you look again at the night sky after understanding all of this, it feels different. Not smaller. Not larger. Just quieter. The stars are no longer symbols of destiny or mystery alone. They are distant furnaces, obeying rules, burning through finite fuel. They are not watching. Earth is not being observed by the cosmos. Earth is observing the cosmos. That distinction matters. It means that responsibility does not flow downward from the universe to us. It flows upward from our understanding to our actions. Knowledge does not arrive with instructions. It arrives with context. And context is what scale provides. Context tells you that progress without limits is impossible. That survival without adaptation is temporary. That intelligence without restraint is destabilizing. It also tells you that repair is possible. That alignment works. That small corrections made early are more powerful than dramatic interventions made late. On Earth, scale rewards attention. That is why awareness itself is the most valuable resource this planet has produced. Not oil. Not minerals. Not technology. Awareness, the ability to see the system as a whole and recognize one's place within it. That ability did not exist here for most of Earth's history. Now it does. Whether it lasts is undecided. The universe will not resolve that uncertainty. It does not need to. Earth will. And that resolution will not come from expanding outward into the vastness. It will come from acting appropriately within smallness. From respecting thresholds. From valuing resilience over dominance. From choosing continuity over acceleration. These are not cosmic values. They are planetary ones. They only make sense on worlds where everything is close enough to matter. Earth is one of those worlds. When the universe eventually grows dark, when stars fade and galaxies drift beyond reach, nothing we do here will prevent that outcome. That is not our role. Our role is narrower and more demanding. To keep this small system coherent for as long as it can be. To allow experience, memory, and understanding to persist a little longer. To treat fragility not as weakness, but as information. The universe does not care how small Earth is. It does not care at all. But Earth does. And that is the final perspective scale leaves you with. Not awe without direction. Not humility without action. But clarity about where meaning lives. Not in the vastness. Not in the distance. Not in the eternal. But here. On a small planet. At a brief moment. Where awareness exists. And therefore, responsibility does too. What finally settles, after all the vastness has been accounted for, is a quiet realism. Not optimism. Not pessimism. Just proportion. The universe is not hostile. It is not benevolent. It is simply large enough that nothing needs to be personal. Earth is the opposite. Here, everything is personal because everything is close. Systems overlap. Timelines intersect. Effects rebound. On a planet this small, separation is mostly an illusion. What happens in one place eventually reaches another. What is released does not vanish. What is ignored does not stay contained. Scale makes that unavoidable. This is why the idea of elsewhere has limits. There is no meaningful elsewhere for Earth's atmosphere. No external sink for its oceans. No cosmic buffer for its biosphere. The planet is not plugged into a larger support system. It is self-contained, cycling the same materials again and again. Small worlds have no margins. That reality reframes ambition. It does not eliminate it, but it reshapes it. The question stops being how fast things can grow and becomes how long they can last. Not how much can be extracted, but how much can circulate without collapse. Not how far control can extend, but how well balance can be maintained. These are not constraints imposed by ideology. They are constraints imposed by physics. The universe enforces them quietly. Earth experiences them directly. And because Earth is small, violations accumulate faster than corrections. Damage compounds. Delays cost more. Recovery stretches across generations. This is not moral judgment. It is system behavior. Understanding scale means understanding that prevention is always cheaper than repair. And that repair is never complete. Systems rarely return to exactly what they were. They shift, simplify, or reorganize around what remains. On Earth, loss is permanent enough to matter. This is why memory plays such a central role on small planets. Cultural memory. Ecological memory. Scientific memory. Without it, mistakes repeat faster than systems can absorb them. Memory allows learning to substitute for trial and error, which becomes too costly at planetary scale. Awareness plus memory equals foresight. Foresight is the rarest resource Earth has. It is not guaranteed to persist. It requires education, cooperation, trust, and patience, qualities that do not automatically scale with power. But without foresight, small systems behave like large ones until consequences arrive too fast to manage. The universe does not need foresight. Earth does. That distinction explains everything. Why knowledge matters. Why science matters. Why restraint matters. Why care matters. Not because the universe demands it, but because scale does. At the largest scales, nothing depends on you. At this scale, everything you know depends on this place continuing to function. That is not a burden handed down by the cosmos. It is a fact revealed by perspective. The true scale of the universe strips away fantasies of centrality, destiny, and permanence. But in doing so, it reveals something quieter and more demanding: stewardship. Not as a title. Not as ownership. But as participation in a system too small to absorb neglect indefinitely. Earth does not ask to be saved. It responds to how it is treated. That response is already underway. It will continue, regardless of belief or intention. The universe will remain vast. Earth will remain small. And in that imbalance lies the clearest instruction scale can offer. If anything here is to endure, memory, meaning, experience, it will not be because the universe made room for it. It will be because, on a small planet, during a brief window, those who understood how small it was chose to act accordingly. That choice is not cosmic. It is local. It happens here. It happens now. And it happens at the only scale where choice has ever mattered. What remains now is not a conclusion added on top of everything else, but a realization that quietly settles into place. The universe never asked to be understood. Earth never promised to last. Meaning was never guaranteed. And yet, here it is. On a planet so small it disappears when viewed from the right distance, meaning emerged anyway. Not because the universe required it, but because conditions briefly allowed it. That allowance is fragile, temporary, irreplaceable. This is what scale ultimately teaches. Not that we are insignificant, but that significance is local. It lives where systems are small enough to feel change, where memory can outlast impulse, where care can still alter outcomes. Earth is one of those rare places. It does not need to be central to matter. It does not need to be permanent in time. It only needs to remain coherent long enough for awareness to continue. The universe will keep expanding. Stars will keep burning out. Galaxies will keep drifting beyond reach. None of that depends on us. But everything we have ever known depends on this thin layer of life, wrapped around a small rock, orbiting an ordinary star. That is the final perspective the true scale of the universe leaves behind. Not awe that paralyzes. Not humility that erases responsibility. But clarity. Clarity about limits. Clarity about fragility. Clarity about where attention belongs. The universe is vast beyond comprehension. Earth is small enough to be cared for. And between those two truths lies the only place where meaning has ever existed. Here.